So today we'll be talking about object-oriented programming and specifically how to create objects in Python. This is a key concept for this course and for object-oriented design and programming in general. This is going to lay the foundation for all programs that come next. We're going to be talking about object-oriented programming, both its theory and its benefits, as well as specific aspects of object-oriented programming in Python. How to create objects, how Python differs from the pure theory, tricks and quirks of programming objects in Python, things like that. So the question becomes, why are we doing object-oriented programming? This is a little beyond the scope of where you're at right now and around beyond the scope of this course, but there are other ways to program. And Python actually allows you to program in a procedural way by using things like variables and functions. Right? These are structures that we've already seen. We've also seen, depending on your background, arrays or lists. Right? Lists are how Python implements arrays. So what do these three things have in common as we've been coding them so far? And more specifically, I guess the question is, what can they all access? And the answer is they can all access each other. They have what is called a shared state space. What does this mean? What does it mean when we talk about program state? Well, program state is the current condition of the program. What is your data? What are the various flags? Where in the program are you? For instance, you open up Word and you open up a new blank document. Well, you have Word, Microsoft Word, in that state where there is a document open and it is totally blank. If you start typing in it, now the state has changed, the state of that program. Additionally, if we go back to the example program from Module 1, the state of the GPA calculator is different when it starts than when you have typed in a few grades. Right? A blank program has a different state. If we were to try to model certain specific things, right? Let's imagine that we were creating a video game and we had our player character and they had certain hit points and conditions and items, right? These are aspects of our player. But in a strictly procedural method, like we've been doing so far, like happens in C, you would have to name variables for like HP. You'd have to go PC _ HP. And you would have to know as a developer that you don't touch that unless you want to access the hit points for the player character. Now, most video games aren't made by one person in their bedroom. There are exceptions, of course. But like a big video game, you don't develop this on your own. So now not only do you have to remember, that you shouldn't touch that unless you want to adjust the player character's hit points, but you also have to make sure that everybody else knows on the team that that's what that represents. And you have to trust them. You have to make sure that they are not just aware, but trustworthy. This is a big deal. People all the time do what they shouldn't. So what object-oriented programming and object-oriented design says is, okay, let's take this choice away from someone. Let's build in to our language the ability to segregate state space, so that each object, the concept of an object, is its own program that has its own state space. It can keep track of its own information, and it can control that information. So if one object wishes to know the state of another object, like we just had, hey, I need to know the state, the combat engine needs to know the state of the player character's hit points in order to know whether a hit kills the character. It still needs that information. So how is this done? Well, the information, the access to the information can be explicitly granted. I think it's Java, where lists and arrays have, you would access it if you had an array. You would access the length of the array using the .length or .len. It's been a little while since I've coded in Java. I apologize. You would call the name of the array .length, let's say. Now, we've talked about this. When you call a method, how do you call a method? Well, you object, .operator, name of the method, and then we're missing our parentheses. And the reason is this isn't a method. This is a variable. This is an internal variable to this object that the design of the object has said you're allowed to see that. It has explicitly granted other objects permission to see that variable. This is the less common way to do it. Okay. The more common way is to communicate via message passing. The idea that there's a communication channel that is specifically provided that objects can speak to each other. These are your methods. Hey, the list object, I'm going to put a capital L because a lowercase l looks like a 1, dot append and then 5, right? Hey, I got a message. Here's the format. Here's the meaning behind it. Here's any additional information that you need. Do what this thing is supposed to do with that information. Okay. Allows you to change the structure of L or to access the structure of L. There is a specific methodology that allows you to do it, right? And it is given. It is decided at design and implementation time. If one of these two methods are not provided, you can't get to the information. And what this does is this prevents unauthorized access across different state spaces, right? I can't see inside of another object. I can't see inside of my player character object to see its HP unless I use the door provided by the designer. And what this does is it gives the object and the designer of the object control of its own information. So you can have truly private information that no one else can see, and you can control that. Or conversely, you could have information like the status, right? PC.status. Well, the status might just be a 1 or 2 or 3 or 0, where 0 means fine, and 1 is fatigued, right? And 2 is poisoned, and 3 is dead, right? But you don't want people to see the numbers. You want them to see the statuses. So you can store these values internally as numbers, and then when another program says, hey, I need the status, it will spit out, oh, it's a 0, well, I'm going to spit out fine. Hey, it's a 2, I'm going to spit out poisoned. Objects have control of its information, how it's accessed, and how it's returned. This is the central theory to object-oriented programming and design. So, more formally, what is object-oriented programming? Object-oriented programming is an imperative programming paradigm where programming problems are modeled as sets of objects. Okay. Now, these are some wonderful vocab words and a little outside the scope of this class, but this imperative programming paradigm you will see more of when you get to, I believe it's CISC 325, where you're going to take a look at different programming paradigms and how languages are structured. What this means is an imperative programming paradigm is one where you give the computer instructions and the instructions are executed sequentially. Not all programming languages look like that. That's what we think it looks like, because that's kind of how all the languages that are easily accessed are formatted. But there are other options, such as functional programming. A lot of artificial intelligence languages are functional programming languages, where everything looks like parentheses hell. If anyone's done any moderately complicated formulas in Excel, that is a functional programming paradigm, where you call a function and you give it data and it outputs something, and that output might be an input to another function, and then you do some math and you do some string formatting, and then that becomes an input to another function. That's a functional programming paradigm. And the other one is declarative. This looks more like SQL, where you say, here are the facts of the world. Please figure out how this stuff works and give me what the resultant world state is. If you take artificial intelligence with me or Professor Chu or both of us, you will definitely run into some declarative programming. So that's what that means. But object-oriented programming is almost always an imperative programming paradigm where problems are modeled as these sets of objects, right? Okay, well, what's an object? Objects encapsulate both the state and the behavior of the program, right? State is the current condition of the program. So this is the values of the internal variables. And behavior are the actions that can be taken, right? These are your methods. These are the things you can do, right? In Python, a string object you can call uppercase, right? It's not to upper, that's C#. It's dot upper, or you can remove the white space from one side. R trim will remove it from the right side of the string. L trim, or it's strip. R strip will remove it from the right side. L strip will remove it from the left side. Strip will remove it from both sides. Okay, these are behaviors that you can do. So that's what the methods represent. State are the internal variables. Methods are the behavior. Methods are also the messages that are passed between them. Okay? Objects communicate by passing messages between them. And it's not just the method in this case. It's the parameters into the method and the return values out of the method. And we'll go into more about what a method is in a minute. Objects know how to communicate with each other, but all other implementation details are hidden in a black box, and that's in quotes. So what does this black box mean? A black box is a concept in software engineering and in many things, right? You know, when we think black box, a lot of us probably think an airplane, the black box recorder. And it's a similar concept, right? What goes on inside that black box, which on an airplane is actually, I think, bright orange, but that's a different thing. Well, we don't know, right? The black box is black. You can't see inside of it. But we know how to interact with it. So we know what goes in and what comes out. I've got the string BG, and I'm going to call upper. Okay, what went in? Well, my object and no parameters. What comes out? BG, capitalized. How's that work? What went on inside? The answer is, I don't know. Right? That is actually the correct answer. Now, you and I know how strings work and can probably take a guess at what's going on inside. It's probably doing some checking of ASCII variables or Unicode variables, right? Turning each character in the string into a Unicode value and going, hey, is it within the range of the Latin alphabet? And if so, let's do some quick math and let's translate it to the uppercase version of that Latin letter. But we don't actually know, and we don't need to. All we need to know is this comes in and this comes out. If on the inside of that black box, the program goes, oh crap, oh God, what do I do? Okay, I got a string of 2 characters. I'm going to randomly guess. And I'm just going to slap some characters together and give it a string of length 2. It doesn't matter if that's how the program works, if the program always works, if it meets the requirements of its interface. What do I mean by that? If the inputs and the outputs work as designed, I don't care how it works behind the scenes. That I'm going to guess randomly thing, that's not a great way to ensure that it always works. But if that's how it works, that's how it works. Okay. So we can see inputs and resulting outputs are defined, but how they are determined is unknown, and it should be unknowable. Okay, the key concept behind all this is if you are designing code in one object based on the internal workings of another object that is not publicly expressed, then you are breaking object-oriented design principles, and you're probably making your life way harder. That's both bad object-oriented programming and bad software engineering. Now, certain things like performance, you might take into account, but those will be publicly expressed, and so that's okay. We'll get into more of this. This is high-level stuff, but this will make more sense in a few minutes as we start to go through things, and hopefully it'll make even more sense by the end of the module. And in case anyone's curious, Wikipedia has this list of common examples of object-oriented languages, at least as of the last time that I went to look at it. This is not an exhaustive list, right? But all of these are object-oriented languages. Smalltalk down here, this last one is the first object-oriented language. So object orientation really came into vogue in the mid-90s with C++ and specifically Java. And Java was the first kind of breakout viral object-oriented language. And JavaScript took on a lot of the trappings of Java, even if it wasn't a true object-oriented language when it started out. JavaScript now has many, many features of object-oriented programming. But Smalltalk back in, I believe, the late 60s was invented in order to do this state segregation experiment, and has been used kind of in very, very niche circles ever since.